You caught me off guard. I didn't think you were actually going to have some numbers. Hold on. All right. What do you have?
29 degrees, 40.5 north, 36, 57.0
west.
That's got to be within a few miles.
That is certainly within the parameters.
That was a clip from me on McToon's channel not long after he put out his $10,000 Flat Earth Celestial Navigation Challenge, where he gave us the information to 3 stars and challenged us to give him the location based on a flat Earth. So he does a couple videos and makes these comments like flat earthers are incapable of giving him the correct location. So I make a refraction model using planar trigonometry, and I showed that 1 degree change over 69 miles gives an opposite side height, or a height of the stars, of 3959. And he claims I used a globe radius, but truthfully, I found out then that it's the globe that hijacked radius from planar trigonometry. So whatever, he had some strict rules. I take it with a grain of salt. So I go to use the AE map and just do the transforms because it's a legitimate coordinate system and he knows it. And he figures that out and then claims we can't use a AE map. All the shit they talk about the Gleason's map, AE map being wrong, but we can't use that. That's funny. He never mentioned that we can't use a flat earth map in the challenge. And when he's running his mouth, he doesn't say anything about us not being able to use the flat earth map. But I'm going to show you, because he found out that it does work for CellNav, and I'm going to show you what he tries to use as an excuse to not allow it.
You know, the Gleason map in the patent says it's an extortion from the globe. That's why you couldn't use it, because it's labeled as an extortion from the globe.
So I think Gleason was a genius, man. He covers this bullshit excuse. So this is from the patent. The utility of such a computing map will be obvious not only to the school child, but for an adult or an official person. The map is not so extorted as to lose the relative latitude and longitude of any places on the land or sea, but retains all latitudes and longitudes of places agreeing with other recognized authors, and as the proper relationship of continents and countries all stand in their relative position to each other, they are thus impressed upon the mind of the student. The extortion of the map from that of a globe consists mainly in the straightening out of the meridian lines, allowing each other to retain their original value from Greenwich, the equator, to the 2 poles. So he doesn't use it extorting like extortion in court. He says the map is not so extorted as to lose the relative latitude and longitude. And then he says the extortion of the map from that of a globe consists mainly in the straightening of the meridian. So let's look at the definitions. Let's find some definitions of extortion. So this is what Toon is implying. Extortion is the wrongful use of actual or threatened force, intimidation, or even violence to gain money or property. So Toon is implying that he stole it from the globe, but I've showed in other videos that the AE map was around way longer than the globe. Let's look at some other definitions. So X is a prefix meaning out of or without. You know, from, so torsion, the act of twisting or the state of being twisted, especially of one end of an object relative to the other. Or in mathematics, the extent to which a curve departs from being planar. So you think that's what he meant? The extent to which a curve departs from being planar? Or theft? I mean, it's pretty obvious that Toon's grasping at straws.
If you use the Gleason map to do celestial navigation, you're admitting the Earth is a globe. So how are you putting the celestial sphere, which is not flat and doesn't map easily to a flatness? How are you mapping that to a flat? No, the celestial sphere is a full sphere.
So which is it, Toon? Are we admitting that the Earth's a sphere using the Gleason's map, or is the celestial sphere a full sphere around the Gleason's map? I mean, give me a break.
So why can't we use the Gleason's map? Explain
Well,
it.
when I do in this book, this process for celestial navigation, right here, here's the book. This here, this isn't using a map. This normal celestial navigation, how it's done commonly, there's no map involved actually.
So he's right. We don't even need a map. So the Gleason's is a legitimate coordinate system, and here's a model that he refused to pay out. We claim it is possible to create a representation of reality where the Earth is represented by a disk. The method by which this model is created can be generalized to any shape, even a globe. In physics, once you have two models, one generally devises a test to prove which model is correct, or one tries to prove both models are equal. In this instance, it can be shown that the flat Earth model is equivalent to the globe model. This can be done by a coordinate transformation. The rest of this paper will first explore the coordinate transformation. Intuitively, it can be seen that lat-long coordinates are invariant between flat Earth and globe Earth. All formulas that work on lat-long coordinates will work on both models. Habersign, for example, will produce correct distances on a flat Earth model, which I'll show that in detail here in a minute. 3. There exists a transformation from Cartesian to latitude-longitude coordinates, and so all physics formulas can be converted into shape-agnostic ones. 4. Extending this to 3-dimension latitude-longitude distance will complete this work. Definition. Any point in Cartesian space, xyz, can be represented with celestial coordinates, azimuth, altitude, distance, relative to an origin. All points on a sphere around this origin with radius d will have the same distance in celestial coordinates, i.e. all the coordinates will look like azimuth, altitude, d, i.e. a flat 2D structure at height d, azimuth, altitude can be drawn like AE projection map. Azimuth as an angle around the center, altitude as a distance from said center, and by doing so, 3D space will be transformed into an infinitely high cylinder. Remember earlier we read that all formulas that use latitude-longitude coordinates will work on both models. Habersign, for example, will produce correct distances on a flat Earth model, okay? So we can apply it to a globe Earth model, taking measurements from a flat plane, but we can't use Habersign in reality on a globe, and I'm going to explain why. So the Habersign formula in a nutshell is taking multiple angles, elevation angles or altitude angles, and multiple azimuth angles, and taking the sine of the azimuth angles, averaging them out, and averaging the sine of the elevation angles, and multiplying them times a fictitious radius, and deriving a distance. They're literally bringing it all down to one plane, and I don't see how they could combine these azimuth angles to one plane. So they literally do need a flat plane to even use the Habersign. It's the irony of all ironies. Look at the picture on the left and on the right. So on the left, they literally have to do their math from a fictitious spot and add a radius, and then project it back out onto a globe when they're just using a plane the whole entire time. And it goes on to say, azimuthal transformation is lossless and reversible. Yeah, it's reversible because that's how they transformed the actual Earth into a sphere. It is a coordinate transformation, not a projection. It's just like polar coordinates and Cartesian ones. They represent the same thing in a different way, and you can easily switch back and forth between them. So this is why McToon will not let you use an AE map. So McToon has a flat Earth challenge where we cannot use the flat Earth model to enter it. So basically you can't use latitude and longitude. So you already knew it was bullshit, but there's the bullshit detailed. Now I'm going to show you that the azimuths can't be on the same plane on a sphere. It only works with perspective on a flat Earth. So allow me to demonstrate this. So we go to the celestial almanac. We see the GHA for the sun starts off this day at 183 degrees longitude, okay? Then it goes to 198, that's 15 degrees. An hour later, 213, that's another 15 degrees. Hour later, 228, that's right at 15 degrees, and so on and so on and so on. It's 15 degrees an hour. Okay, so it's doing circles around Polaris. around the Greenwich hour angle, or the basically starting zero at the prime meridian, wherever it's at. And then you see the declination right next to that, which is not to be mistaken with elevation angles or altitude angles. It's angles from the equator. So S obviously stands for south and N for north. So the declination is angles from the equator. Okay, so we see that at every hour, every day, 15 degrees. So now we go to sun calc to see what we measure in reality. So we see east is roughly right at 90 degrees, and 180 degrees away is west at roughly 270. So here we have a 12-hour day. So let's see what we measure. So we're going to start at sunrise at 7:30, and we got 89.94. We'll say 90 degrees. 1 hour later at 8:30, we got 97.6. That's not 15 degrees. Now an hour later at 10:30, we got 106. That's only 9 degrees. An hour later at 10:30, we got 116. This is not 15 degrees an hour. In fact, in reality, the azimuths we measure are seldomly 15 degrees an hour. And the Globers love to claim the sun moves 15 degrees an hour. So we cannot possibly be measuring these from a single point on a globe, because the sun should be circling around at 15 degrees an hour. They use like infinitely far celestial bodies, and that throws out perspective. But the flat earth uses perspective, I mean, to explain a lot, including this. We wouldn't expect a 15 degrees an hour. We'd expect it to start off slow and speed up as it got overhead, and slow down as it departs. And that's exactly what we measure in reality. And this is sun calc proving that. So this is my contribution to the FED guys. The Habersign formula, you're going to need a flat earth for that. Thanks for watching. Please like and subscribe.